So what are we going to talk about? If we want to talk about data visualization, we also have to talk about statistic analysis. And I'm pretty sure you already had 1 or 2 lectures where you were talking about statistics, but just to recap all of that, we will talk briefly about descriptive analysis, explorative analysis, inferential analysis, causal analysis, and predictive analysis, and how to differentiate them. So what is descriptive analysis? Descriptive analysis is trying to describe the world around us with data. And in this case here, we have red and blue flowers, and we have numbers below those flowers. And now we can write all of those numbers differentiated into the 2 groups, red and blue, into a table. And that's nice. Yeah, you have the table, but you don't really have an overview. Okay, what do I do with this information now? You can calculate, for example, the mean and the median value of those red and blue flowers, which is done on the table on the right. But you can also visualize that information with, for example, this box plot diagram in the bottom here. And you see with the box plot diagram, you see, okay, where is the mean and the median of my data, and how large are the deviations around the mean or the median value here. And so you have a very condensed, very visual representation of the maybe structured but not very good or viewable data on the left, or even the non-structured information which you have with this flower field in the top. So now if we do explorative analysis, we go one step further. So we have already a descriptive analysis of the world around us, and now we want to dive deeper into what we can withdraw information from the data. Say in the bottom here you see the female to male earning ratio and the median earning of full-time year-round workers by the different sexes. So you see in the bottom graph male and female earnings in thousands, and in the top you see the calculated ratio in percent and how this is changing over the time, and you also see an indication of recessions with these gray boxes. And you see that the ratio is with a slight upwards trend, and you see in the bottom that the male and the female curves are like still not on the same level, but they are narrowing down a little bit over the years. And so this is an information which you can see from this representation of the data, and especially with the calculation of the ratio in percent, you can now really see, okay, how is this ratio changing over time. And so this is explorative analysis, because you are taking the data and you are combining it with other observations. So observations for male and female earnings, or male and female workers and their earning, and you calculate the ratio out of it to show and to explore, okay, what is happening, what trends can you see in the data, for example. Explorative analysis can also be that you have data and you visualize it to look into it. Okay, what information can I draw out of the data now? So for example, here we see the penguin sizes of 3 different penguin species, differentiated by color and by the symbols. So with the green one, the purple one, and the orange one. And you can now have one of those scatter plots on the upper part, and you see, okay, here you have a certain clustering and grouping, and you can now also produce a frequency overview of the penguin lengths. So you have the flipper length in millimeters on the x-axis, and you have the frequency on the y-axis, and that way you can also see, okay, here are peaks, and you can see, okay, how this is interrelated. And you can now also set the flipper and the bill length into perspective, and you see like those regression lines within the scatter plot on the right, and you can see, okay, there is there might be an interlinkage of the 2 parameters in the x and the y axis. Yeah, so that way you can now also identify, okay, is there a combination, is there a correlation, is there an influence of one data point or one data set on the other data set, how are they interlinked, and what information can you draw out of that. If we're talking about inferential analysis, then it's the process of using data analysis to infer properties of an underlying distribution of probability. So inferential statistics analysis infers properties of a population, for example, by testing hypotheses and deriving estimates. So if we now look at a population of 1,000, for example, website visitors, and we have a sample of 1,000 randomly selected visitors of this full population, then we can split the sample into two randomly split halves, so 500 on one side and 500 on the other side. And now we can try different things with those visitors. So we can, for example, modify the website, and we see within the blue use case we have a 60% click rate, and with the green one we have a 90% click rate. And now we can use statistics to compute a probability. And if we have then statistically less than a 5% probability that the results are due to the changes, and the things will be changed with the green version here, then it might make sense to change the button to green, because the click rate is higher, and we can infer that if we change it now, then this click rate will also be different for the full population. We have a higher click rate, and if you want to have a higher click rate, then we can do this here. So this is a very common type of inferential analysis that's being done in web development. So you do these A and B tests, but you can also imagine other experiments and other hypothesis testing where you could do the same in order to find out, okay, what should I do, how should I behave, what information can I infer from data, and how should I set up also an experiment to confirm or disconfirm a hypothesis that I have. So now if we look at causal analysis, then for example here we can see the popularity of the first world problem meme in correlation with the Google search for zombies. And when we do causal analysis, we have to keep in mind three big points, so for a good experimental design, because causal analysis is also often, as well as the inferential analysis, linked to, okay, we're doing experiments and we try to find out and test our hypotheses. And so what we have to keep in mind is, okay, our experiment has to be replicable, so we have to gather enough subjects to support the statistical analysis. So for example, if your population size is very, very large, but you're drawing out a sample of just one person, you would say, okay, this person is not really a good representation of the population. And that way, if you would redo the experiment, you have a different person, and then it's also not replicable. But if your sample size is, for example, large enough, then you could just repeat the experiment with the same sample size and you would get the same results. Also, you have to keep in mind randomization. So assigning subjects randomly into treatment groups, for example, if you're doing medical treatments or with the web development, so we had this random split of the sample group, and so you have to ensure that this really is happening on a random basis, because if not, then the two sample groups or the two test groups would not be the same, so to say. So each subject has to have the equal chance to be selected for one of the two groups in order to ensure that you have really representative, really groups that are representative for your population. And in the end, you also have to ensure that you have control. So you control all factors that are not in the experiment's focus, but could influence the outcome. So, for example, if you're doing some sort of temperature testing and you're testing, for example, a material under different temperatures, you have to ensure that your lab where you're doing the testing has a stable room temperature. So if this is shifting, that might influence the results, and if you don't control for that, for example, you measure the temperature within your lab, and if you don't do that, you have an influence from outside on your experiment, and that way this would influence your results. And so with the causal analysis, why I'm showing you this graph here is, okay, you can identify now a correlation, which you can see in this graph, between two data points. And in black you see the relative volume of Google searches for first world problem within the United States, and in red you see the volume of Google searches for zombies, also within worldwide, not within the US. And you see those are like peaking more or less at the same point. And now you could say, okay, yeah, we have first world problem, we have zombies. Yeah, but on the other side, you can also try to understand, okay, what happened during that time. So yeah, you had a large TV series coming out, and so maybe that was also influencing the search term for zombies. And first world problems meme occurred during the same time, maybe also because all of those catastrophe series and movies had a peak in 2011. And so there are external events influencing both search behaviors. And so keep that in mind when you're doing causal analysis or when you're showing data. Often you don't have a correlation or causal interlinkage between two data points, even though you see it in a graph, and you could do it in a graph like here, and you might have a correlation, but that is not implying causal relation. But if you if you're focusing on controlling all factors, if you're randomizing, and if you ensure replicatability, then often you can already bust those not good experimental designs and ensure that your causal analysis is better. So predictive analysis builds up on all of what I said till now. So you have a set of known data, for example, red and blue berries. So you have raspberry and blueberry, and you have a model which is now looking at different parameters, for example, the color. And now you have input data. We didn't know how this data is classified, for example. You throw it at your model, and then you have an indication, okay, this is raspberry. And keep in mind, when doing predictive analysis, you have to also keep in mind, okay, what I'm doing it for. So for example, if you are producing a model or an algorithm to decide what movie to look next or to watch next, a Netflix recommendation algorithm, this is rather low risk, because if your model is faulty or if it has biases, there is no real risk. Yeah? So if you classify, for example, in this case, raspberry as blueberry, okay, nothing really happens. If you're looking at toxic mushrooms, this might be a little bit different, because if your model then says, okay, this mushroom is not toxic, but it's a toxic one, that might lead to death, or at least people going to the hospital. And even worse, or depending on how you decide if things are worse or not worse. But for example, also if you look at the grades of students, or if you look at law enforcement and so on, and then you have to ensure that your predictive analysis is really good, and you have your false positives and positive false really under control. So again, we will do a little review, and we will do a little exercise here. So stop the video and try it out yourself. So I have here a bunch of different sentences. For example, you want to know whether a resource is critical or not. What type of analysis would that be? So please stop the video now and try to match all of those sentences with the different analysis types that you learned within the last minutes. So as you stop the video and tried it out yourself, So with the criticality assessment, you want to know whether a resource is critical or not. That would be a causal analysis. Yeah? You are interested in how several variables in a data set relate to each other. This would be an exploratory analysis. You have a brand new data set and need to get an idea of its size and distribution. So you would do at first a descriptive analysis to get an understanding, okay, describe what is this data set looking for. Yeah? If you need to test a hypothesis, so you already have a hypothesis, but you can only work with a subset of it, yeah, because you cannot look at the full population, but only at an sample size of it. And to test your hypothesis, then this would be an inferential analysis. And if you have a data set, a database, for example, of products, and you have an identification if they are sustainable or not sustainable, but you also have 10,000 new products, for example, and you want to classify them with the knowledge you have from your existing database, that would be now a predictive analysis in order to decide if those 10,000 new products are sustainable.